Okay, now welcome to module 3 of software engineering. So in this session, we will explore coding standards, documentation, and version control systems. So these are basically practices that will define professional software development. Okay, so let's begin. So let me ask you something. So if suppose various developers maybe like 4 or 5 developers write code in different styles, what will happen to the project? It'll become confusing, right? Which is why coding standards exist. So basically, coding standards are structured rules. Okay, we've already discussed a bit of this in module 2. So these make it structured, like introducing best practices which are followed while writing the source code. Okay. So they ensure consistency, they ensure clarity, they ensure maintainability, etc. Okay. So basically they help teams think in the same structure when a lot of people are working on the same project. So why project need coding standards? So in real projects, developers join and leave, right? So the code keeps evolving and the features will be added, and without any standards, the debugging will become harder. And what else? Yeah, onboarding of a new developer will become very slower, right? So maintenance cost will increase and all that. So standards basically are not restrictions. So you should understand that they are safeguards. So now consider naming. So we are digging deep into coding guidelines and standards. Okay. So if I write a function called maybe CALC, right? So what does it calculate? We don't know. It's generally, yeah, we will get an idea that it is going to calculate something, but we exactly do not know, right? So if we write instead of CALC, if we write something like calculate total practice, it's shown as an example here on the slide. So the intent becomes very clear now. So names basically must communicate the purpose. Is what we are trying to say. So clear naming will reduce all that mental effort, extra mental effort. Okay. And software engineering is about reducing the cognitive load, basically. So now, moving to intentation. So look at properly intended code. So what do you understand? Like you can visually understand the structure, right? If it's a properly intended code. So this you would have already learned when you learned coding. So formatting is actually not decoration. So it's actually the structural clarity, right? So readable code is actually the best maintainable code, right? So you can visually understand the structure while intending, like loops, conditions, blocks, everything becomes clear. And through the formatting, we get a structural clarity, is what we understood right now. Okay. Now, what about comments? You all would have written your own bit of comments while you started your coding from C language or Python or whatever. So comments should explain why something is done, right? Not just what is done. So because future developers or anybody who onboards new, or maybe even your future self, when you get back to a code which you had actually left half the way, you may not remember the logic. So code is written for humans first, right? Machines will just execute the code. Okay. Now, hard coding, yeah, that's another part of the coding guideline. So hard coding basically means embedding fixed values, right, directly into your program. For example, how do I say fixed values? Say like writing something called a tax, right, uh, equal to 18 directly in logic, but I cannot equate something like tax is equal to 18, because what if tax changes, right? So instead, what you should do, that's hard coding. So you should avoid that. Instead, what can you do? You can use constants or configuration files and then include them. Okay. So flexible software is the one which would actually survive the change. If it's a rigid software which uses a hard coding, the software will break. Okay. Now let's move to like documentation. So documentation basically explains like uh, you know um, how the system works and how it should be used and all that, right? So before we move into documentation, we should know about the quality of the code which we have developed, right? So we will see that with an example. So here, before we look into like hard code documentation, we are here trying to show an example of different kind of code actually. So I mean the same code, different kind of representation. So when we say, so on the left hand side with the red into mark, I've shown poorly written code, and then on the right hand side the same code equivalent which is well written, right? So as you can see, like if it's a poorly written code, it will not clearly uh, name the variables which are used. Whereas if it's a well-written code, you can see that, clear naming conventions are used. Okay. And then about indentation, which we studied, there'll not be any indentation in the poorly written code, whereas in the well-written code, you'll have a consistent indentation. And then about the missing comments, about the hard code values, about understanding the logic flow, about any developer being able to modified safely or not. All this is actually listed as for easy comparison. I've listed it in either sides. Okay. Yeah. Now that we've seen this, we will now move into proper documentation. Okay. So what is documentation? You all know, right? So basically it explains how the system works, right? So how it should be used, and maybe later, for a later time, how it can be maintained. Yeah. So think of this as a permanent knowledge base, okay, of the software project. Fine. So now that we know what documentation is, so we should know what are the various types of documentation that we could make. Okay, so moving to the next slide. So basically there are three types of documentation, okay, so which the user can use, okay, that is called user documentation, which the uh, developers can use, which is basically the technical documentation, and uh, another kind of documentation for uh, future updates and system support, etc. So basically, which is why it is written there as it can be any user manual, it can be any technical specification, it can be any API references, any design documents, any troubleshooting guide, right? So why is documentation essential? So we said there are three different types of documentation. No, what is that we said? Just revise once. User documentation for end users, technical documentation for developers, maintenance documentation for future updates and system support. Yeah. So it enables all the users, all the development team, and all future people for the system support. Yeah. So this is what we saw: user, technical, and maintenance documentation. So in detail, so user documentation is designed for the end users, as we said. So what all can it include? It's written very clearly. It can have user manuals, quick start guides, any frequently asked questions, any video tutorials which will help the end user. So basically, how does the user uh, have to work while we use this software is what it means. And then technical documentation, as I told you, basically it will be having all system architecture, diagrams, database schemas, code comments, design specifications, everything. So basically, this helps the developers to understand what the code base looks like, right? So that this is the technical level documentation. Yeah. And then the last one, we said, is the maintenance documentation. So as I said, this will be for future updates and basically for the system support. So it can have change logs, it can have the issues which are currently known, and then how to the procedures to fix the bugs, and then any guide for the deployment and etc. All these. So this is valuable when the actual team or the original developer which developed this has actually exited, and probably when new team members will have to understand about what the current system does. Okay. Okay, now we move to version control system. So we've already seen a bit of introduction of version control, why, what, and all in the previous module, in module 2. So let's just revise that. So have you ever overwritten a file by mistake? Yes, right? Or maybe struggled during any group project when multiple people would have edited the same file, even if it's a report, right? So basically, you can equate this to version control system. So these kind of systems will track who changed what, when, and why. Okay, so they allow us to revert to the previous safe versions. Okay, so basically problems when whatever problems occur when people work together, I mean multiple people work together on a project. So what does this version control solve is what we have written on the right hand side. It prevents code loss, and then it enables multiple developers to work simultaneously. Then it will give an answer to who changed what part and when did they change it, and then it will allow trying new features without breaking the working code, current working code, and then it'll also provide automatic backup, and so that we can recover easily, etc. Okay, so now moving to Git and GitHub. This is something which also we've discussed in module 2. So what is Git? You all know because we've already discussed this. Still, I'll revise. So Git is what? It's a distributed version control system, right? So it what does it do? It tracks changes locally. So now what is GitHub? So GitHub is a cloud platform which will host the Git repositories. All these we've already discussed. I'm just revising. So Git basically manages the versions and GitHub will enable the collaboration. So together Git and GitHub, what will they do? They will power module development teams. So this we have already seen. Now, so this is a very important slide. So this shows the entire GitHub workflow from the code to the collaboration, right? So the workflow is simple. So we can write the code, then we can commit the changes with maybe meaningful messages. Then you can push it to the repository. Um, so after pushing to the repository, team members can actually collaborate, pulling the updates. So this will basically ensure structured and controlled collaboration, right? Okay. So now we have like examples given here. Talking about real life application or real world applications, we've already done a lot of innovative activities, taking examples of all these professional software development in the real world, right? So we can have examples of college management system. They you know what it will do. You can have examples of industry software projects. We've done this. And then basically, whether it's a startup which is building, small apps, or an open source community which will be creating major tools development, which actually relies on, professional practices. So all these will transform all individual programmers which will work on this into cohesive, productive teams, which is capable of building complex software systems, right? So, professional software basically, or software development is just not about writing code that works, it's about writing code that lasts, right? So, what were our key takeaways today? Just to summarize, so we've had what are the basic coding standards to improve quality. We've seen all that. And then, while doing documentation, how will it support maintenance and version control, which will enable collaboration. We have seen Git and GitHub, how they track every change, enable multiple developers to work simultaneously, and then prevent any loss, which happens, and how it can transform software development from being a very solo activity into a team effort, collaborative team effort, right? So these are all like pillars of our professional development. So that's all for today. So in the next class, we will apply these concepts practically. Thank you.